All right, good afternoon, everyone. Uh, Thank you for being here. Again, welcome to the Making Traffic Signal Data Usable for Agencies webinar. As we see more people trickling in here, we'll just slowly get started, okay? So my name is Ayrton Coles. I know most of you from previous webinars and classes that we've been together, and I'll be your host today. In the name of the University of Tennessee Center for Transportation Research, the Tennessee Transportation Assistance Program, TTAP, and the Traffic Signal Academy, I would like to thank you for your participation. Like I mentioned before, we received close to 90 registrations for this webinar, so we should see some more people trickling in from about 12 different states, Canada, and actually we have a friend of mine that registered from South Africa. Hopefully he'll be able to make it. We welcome all of you. This is our second webinar for a year, and the idea is to bring your information on the use of traffic signal data within agencies, its challenges, benefits, workforce needs, etc. You can find our previous webinar on YouTube. Just look for the Tennessee Transportation Assistance Program channel. I would like to thank Patrick Landy and Sajad Shiravi at MyoVision for partnering with us on this webinar. And before we get started here, let me go through some housekeeping items. Let me just move my screen. So the first thing I'd like you guys to do is to please sign your name on the chat box. And if you don't mind, just let us know where you're logging in from. Just put the name of your city or agency and state. Please make sure that you have your audio on mute. I'll be trying to control that on my end, but if you can help me out with that many people, sometimes it's hard to make sure that everybody's muted. Just make sure that you are muted. Try to avoid using your camera. I'm just going to use my camera here in the beginning. And again, towards the end of the session, we'll have a Q&A. So use the chat box to ask questions, okay? You are going to get a PDH certificate. We'll be sending that to you in the next 2 weeks, but we definitely need your name on the chat box because we check that with the registration to make sure that you attended, all right? You should have received an email this morning with the information for the Zoom meeting, of course, and also on how to download the materials that we'll be presenting today. If you're not able to do that, send me an email after the presentation here. I'll be glad to share the material with you, okay? With that said, let me present you our presenter today. Let me introduce you our presenter today. He's Sajad Shiravi. Sajad is a product manager at MyoVision. He's a professional engineer in Ontario and has almost 10 years of academic and industry experience in transportation engineering. His main focus has been on new sources of traffic data and developing methods and products that turn data into impact. Specifically, in the past 5 years, he has been working with traffic signal performance measures, helping cities incorporate high-resolution traffic data into their workflows. So Sajad, thank you very much for being here, and I'll stop sharing my screen and I'll let you share your screen and go from here.
Thank you very much, Ayrton. I appreciate the introduction. Just quickly share my screen here. Share. Can you see my screen, Ayrton?
Yes, I can.
Perfect. Thank you so much. Hi, everyone. This is Sajad. Really appreciate you taking the time today to attend this webinar. Hopefully, it's going to be an engaging one. So I'll get right to it. So the agenda for today's presentation, we're going to start off with sort of a story of usability and why it's important. Shares the results of some surveys that we've been conducting, and that leads into the conversation of why it's important to be able to convert data into insights, common traffic performance issues that we've identified in the past few years, and go over a case study where coordinated timing plans were produced purely using ATSPM data. So this, to start off, this has nothing to do with ATSPMs directly, but please bear with me. So this was an image that was shared a while back on Reddit, and it went viral, and someone was sort of shared it around and said that, oh, look at this, I've grandparents proofed my my grandparents' remote control, their TV remote control, and as you can see, it's very clearly indicated that the here is on and off, and sort of taped all the unnecessary pieces that they don't really need. This is a very simple way of looking at this, but there's a lesson in here, and the lesson is the lesson of usability. It is the lesson of understanding what is the end user, what are they trying to achieve, and being able to produce the methods or products for them to be able to completely leverage what they need. So as you could see, for example, in order to address this problem, on the left you have an Apple TV remote, and on the right you have a Samsung remote, very small, lightweight. You got all the right sort of buttons on it. It doesn't mean you don't have access to those functionalities. It's just in a different place now. Like, it's in the actual system. If someone's interested, they can go and do whatever they want. It's just more about catering to sort of the common user. And on the right, you can see a Samsung remote has net. What do you want to do when you pick up a remote? Well, you want to watch Netflix, for example. Well, there's a button there. You click on it, takes you to Netflix. It might not cater to everyone, but the story here is to how to sort of find that sweet spot where most people will find your product more usable. So again, this is not a product pitch or anything by any means. It's more about sort of guiding the industry towards how they can how to make data more usable, and how the industry can help drive that. So for any kind of task, again, it could be as simple as changing a channel on a remote control, all the way to a traffic signal retiming, which is a complex thing to do. There's an irreducible amount of complexity for that task. You can't make it any more simple than that in order to conduct it. And the difference between sort of different methods and different products is that, okay, how much is the software taking on, and how much is the user taking on? And this is the difference between something being usable and something not being as usable. And ultimately, what you want to do is to reduce the amount of complexity, unnecessary complexity for a typical user, in order for them to be able to use their time, use their resources in order to make the decisions, as opposed to necessarily dig into piles and piles of data in order to be able to get to a point where now they can make a decision. Doesn't mean you don't present that data, but it means that you're just getting them faster and leaving the hard stuff, which is making decisions, picking the right solution, ultimately to the user. And the reason that the reason that I am mentioning this, this speaks to sort of our experience with a lot of our customers, a lot of people that I talk to in the industry, and specifically one of the surveys that we conducted a few months ago. This was an ITE presentation on ATSPMs. There were 500 registrants, and 350 people showed up. There was a split of about 40 to 60 split between public versus private. And one of the questions that we asked was, okay, what are some of the barriers for you to be able to sort of incorporate data, high resolution data, ATSPMs, for traffic management purposes? And as you could see, a high percentage of people mentioned that needs too much time. Data is hard to interpret, not sure how to use the data, and a percentage said that it's hard for them to sort of, may even require some coding for them to be able to get there. So this survey, definitely in line with what we had seen from the industry, what we had heard from a lot of the customers, is that, yeah, this data there's a lot of work in order to be able to get to a point where you can now make an impact. And of course, agencies are very time constrained, and there's a lot going on. So resource constraint doesn't really allow for agencies to be able to get there. Another experience I was reading is this very great report on evaluating the benefits and costs of implementing automated traffic signal performance measures from FHWA. And MCDOT was sort of mentioning their experience with this, and it was quite interesting that one of the needs that was mentioned was a need to orient performance measures towards specific tasks. And this is definitely in line with what I've seen from customers and working with them, is that it's data, right? It's not really converting the data into a task, right? So it's not a task of like, how do you now turn that data into an actual insight where you can make a decision on that? And that's sort of the missing piece with the data. So just want to share sort of our experience with that in what we've seen when you start to help agencies and sort of from a product perspective start to convert that data into insight, what it can result in. So this is sort of a test that we did in our software, where we started to produce some actual insights on top of the data. So being able to not only just present the data, but be able to identify actual problems using the data, like suboptimal green split issues, or if there were coordination issues, or if there were, for example, what's it called, the phase termination issues. And I'll explain why we sort of targeted those. But what we understood was that there's a need to present information, not just data, and you need to be able to find ways to be able to reduce time to investigate. For the academic people sort of on the call, this is definitely an area of research, in my opinion. Like, how can you sort of convert that data into more actionable insight? The need to summarize large amounts of complex data, the need for simple reporting and alerting. So you might be able to find things, but how do you surface that to the user to make it more digestible, make it more easier to understand, and ultimately be able to reduce that time to impact? So our evaluation, I was personally involved in this evaluation. I think where the evaluation is now up to 500 intersections, and hopefully we can share our results soon. These results were shared in the previous ITS America conference, and with the analysis of over 200 intersections, we identified sort of the three top problems that we're seeing, and 35% of the intersections had suboptimal green splits, 38% had phase termination issues, and 41% were experiencing some kind of poor coordination that could have been improved. And all of these were in collaboration with the agencies, with the respected agencies, and it was based on their objective. So they acknowledged that this was in fact a problem, and it wasn't intentional to keep the green splits, for example, in that way. And in other words, these were opportunities. And this was one of the main reasons why, again, it's important to be able to like convert that data. So data doesn't automatically tell you that there's a suboptimal green split or there's a poor coordination. You sort of need to be able to dig into the data to be able to find that. So that's definitely a gap that this tries to address. So when I'm talking about suboptimal green splits, it's when there's an imbalance in performance between the competing movements. And one of the ways to be able to identify that is looking at occupancy and split failure. So using the stop bar detector information for each individual movement, you can create the ring barrier of that intersection during that time of day plan. What are the phase sequences and concurrencies? And then being able to assign a performance to each of those movements. And then that's when you can sort of understand, okay, is there opportunity to be able to move the barriers around by a few seconds to be able to address the problem. So suboptimal green splits are pretty straightforward to be able to identify. So again, you're taking that data of occupancy data, split failure data, that's sort of on a movement by movement basis, and how do you bring that together in order to convert that now into an actionable insight where now you can say, you know what, seems like you can tweak the the left turn here, the green time here a little bit, and be able to address the performance. So again, the way that it's identified, occupancy, number of split failures on the competing movements, and then if the through is showing signs of undercapacity and the northbound left turn movement is showing signs of overcapacity or near saturation, that's when you can identify an opportunity to be able to tweak the signal timing. And again, it depends on whether this was like one day, was multiple days. This is another issue that we came across as well. If this happened just like a couple of days, is it a problem that needs to be surfaced? Well, talking to a lot of agencies, it depends, right? But the majority of the agencies that we talked to were more interested in issues that are happening as a trend, as opposed to issues that have happened one time. So that's another question of like, how do you take that data, identify trends as opposed to one-time issues? And the beauty of ATSPM data is that because the data is being collected on a 24/7 basis, it's possible to identify those. The second common problem that we identified was phase termination issues. This is surprisingly quite common based on what I've seen and evaluated, is that are cases where minor movements are not terminating properly, and these are cases where, again, you need to look at this in the context of the ring barrier diagram. You can't look at this on an individual movement basis, because you could have a minor northbound, southbound that are happening concurrently. Northbound is busy, southbound not as much, but does that mean that southbound is wasting green time? Not at all, because northbound through is the one that it's extending the phase. So that's why it's important for the data to again be looked at in the context of sort of a combination together, and that's what sort of makes it a little bit difficult to interpret the ATSPM data, because the ATSPM data are very movement focused, and it's hard to sort of see the bigger picture and be able to convert that into an actual insight like this. And these are cases where minor movements, they're not serving vehicles, they're not serving pedestrians, not serving preemption, and again, issues that are happening consistently. So sometimes minimum greens are too high, sometimes they're on recall, could be either of these reasons. Usually it's not broken detector, because broken detector is identified through another logic, which is when the detector is constantly occupied, and it's failed high, for example, without a single blip for like more than 40 minutes. So that is that's how you sort of distinguish between like, oh, that's a detection issue versus an actual like signal timing problem where again, either recall, minimum greens are too high, or any other reason. The third common problem that we've seen, poor coordination. Again, this depends on the context and the location, but for the corridors that the aim is to enhance coordination, one of the ways to be able to identify that, in the way that we identified in intersection health, is through green bands. So the again, beauty of ATSPM data, all the data is available. We have the signal timing, the signal phasing, exactly what's happening in the field, right? So it's not what's on paper, it's not what is being designed, it's what's actually happening in the field. And one of the ways to be able to do maybe a quick, I guess, for lack of a better word, a quick sniff test of whether coordination is working properly or not, is to assess green bands. And there you can create sort of an efficiency score based on that, and that's what intersection health does in order to be able to identify that problem. So efficiency score using the green bands based on actually what's happening in the field, and be able to use that to identify corridors that are suffering from poor progression. And the efficiency score, again, this is an efficiency score that FHWA has a method for it, and is based on using both directions, right? So it's not just using the efficiency score for one direction. So here, I'd like to get into a case study where it was identified that a corridor is suffering from poor progression, and then we sort of wanted to see if we could use the ATSPM data on its own in order to be able to come up with a timely plan to be able to address the problem here. So this was in a town where in Canada that experiences a lot of seasonal traffic. So during summertime, there's a lot of people who come to this town and they experience that sort of that seasonality changes in traffic conditions. And there's this major corridor that connects sort of that downtown area to the suburbs, and very directional traffic happens on this corridor. So very heavy on the southbound during the AM, and very heavy on the northbound during the PM. There were a lot of complaints along this corridor, lots of delays. It was even in the news, and the town sort of wanted to, the city wanted to do something about it. So the way that I see ATSPMs is that with ATSPMs you can do sort of an MRI scan on your network. So when you're seeing a problem or you just wanted to be able to assess that, I see ATSPMs as a way to be able to do that MRI scan. It's like the congestion or the complaints that you're getting. It's like a headache that someone has, and then you go to the doctor and then prescribes maybe an MRI scan. I would say like the complaint is that symptom, and then ATSPMs could be that MRI scan that you do on the corridor and see, okay, what's going on really here? Is it that bad? Where is it bad? Can I do something about it? How is it performing? Like all of these questions can be answered using the ATSPM data, and I feel like that's really the beauty of the data. So in this case, what you're seeing on the screen, it's called the congestion scan. This is produced using a travel time information, using Wi-Fi data, using Wi-Fi probes, which is sort of an addition to the ATSPMs. I think travel times goes very well with ATSPMs, and Wi-Fi probes are it's a very cost-effective way to be able to get a really good measurement of travel time. And what this sort of visual that you're seeing on the screen does, there's a sort of a right side to this, there's a left side to this. The right side is visualizing the travel time on the northbound direction, and the left side is visualizing travel time on the southbound direction. And the x-axis here is 24 hours, so we have 24 hours, and each sliver that you can see in this view is 15 minutes. And then on sort of the x-axis, you have the intersections along the corridor, so the different sections along the corridor. And essentially what we do here is that we're using travel time and producing a travel time index. So travel time index is the average travel time over free flow travel time. And this allows, what this index allows is gets rid of the distance, and you can do a apple-to-apple comparison of travel time across all the different sections along the corridor. Of course, if you have a longer section, you could have a longer travel time, but if you divide that by the free flow, which is now the travel time index, you can easily just compare that together. And as you can see here, on the northbound direction, during the PM peak, so again, this is sort of the MRI scan that I was talking about. So AM, like southbound looks okay, AM was looking okay, you look at PM, and then from around, I don't know, 3, 4 p.m. Up until like 6 p.m., 7 p.m., you're seeing a pretty high spike in travel times. You're going from the blue area, which is almost free flow, to 6 times, 7 times free flow travel time. So pretty significant spike that's happening here. So once you sort of do that scan, so again, we're going through, we're diagnosing and seeing what's going on. So the next thing that comes in mind is that, okay, that's travel times are high, like you've confirmed that PMs are bad, and let's go and see if we can do something about them. So let's go and take a look at the controller operation. So let's take a look at what the controller is doing during this time at different intersections. And then that's when this chart comes into play. It's called the phase interval graph. It's exactly showing you the cycles, the amount of green and red and amber that's being allocated to sort of different movements at the intersection. And here we're looking at the northbound. We're looking at the major direction, and we're looking at different intersections along the corridor. And what we're seeing here is that, first of all, it's very clear that cycle lengths are variable. And variable cycle lengths mean that this intersection is these intersections along the corridor are all operating in free mode. So they are not coordinated. There is no coordination happening in any of the parts of the day. And that's common across all the different sort of intersections along the corridor. But not only shows you that this intersection is non-coordinated and it's operating in free mode. If you take a look at sort of those cycle lengths that are happening, those cycle lengths are in fact what's called the natural cycle length. So this is what the system is telling you, the amount of cycle that it sort of needs or it expects. And that piece of information can be used in order to be able to identify what the coordinated cycle length should be in this case. I'll get into that in a little bit, but essentially by looking at maybe a percentile, like the 75th percentile, 80th percentile of cycle times, you can figure out what the coordination cycle length should be in order to be able to produce a coordinated timing plan. Again, like looking into the data a bit more, again, this is the phase interval data. It's showing the cycles. You can see that in a lot of cases, in the heat of the PM peak, where there's a lot of traffic being backed up on the major movement, just because there's one vehicle on the minor, it's terminating the major and it's servicing the minor. So very small interruptions to the major movement. And this is where things are getting inefficient, right? Because you're now not creating the right balance between the movements, and the minors are sort of eating up a lot of that time and interrupting the major quite frequently, and creating a lot of backup on the major. Another piece of data. So again, beauty of ATSPMs, you can line up all the phase interval data. That's sort of one of the graphs. It's a time space diagram, and you can exactly see what the true time space diagram looks like out there. And this is not based on the timing plan. This is not based on synchro or anything. This is exactly lining up the phase interval times and so showing those green bands that are truly happening out there. And it's a really interesting way to be able to truly see the operations that are happening out there. So as you can see here, pretty much coordination during those times are non-existent. The green bands or the green waves are being chopped up pretty badly. And in a lot of cases, as you could see here, what's happening is that the downstream intersection is red, upstream intersection is green, and it's probably creating a lot of green starvation as well at some of the intersections. So very clearly, you can see that that's probably what's happening here. So let's sort of bring everything together. What is our evaluation to this point? So we did a scan. We identified that, yes, this is a problem during the PM peak. Lack of coordination was clear from the type of operation. There seems to be a significant randomness that's happening, major interruptions to the major. And what the data is telling us that, you know what, throughout the day, your free operation seems to be working pretty good throughout the day, right? So it's you can keep the rest of the day as is, if you please, and you sort of want to create that balance between the minor and the major, because performance is telling us that from a travel time perspective, well, things are performing nicely, but there is the PM peak that may require some attention and be able to coordinate. So again, with the agency and sort of working back and forth, sort of identified again those natural cycle lengths really help. Like, what are those natural cycle lengths that are happening during the PM peak, to be able to come up with the coordinated cycle length. And the agency ultimately decided to, okay, let's go with 140 seconds. The good thing again is that, like, you can pick something and you optimize where you implement it in the field, and then you track the performance, and then you can decide whether you should go up, you should go down, and sort of do that assessment. So the agency here, I'm just conveying sort of what they did. So they used a cycle length of 140 seconds, and they wanted to start off with that. So here's sort of the gap again. Be able to like truly optimize that. This is something that we are working on our side as well, but be able to really take that information and produce a timing plan. So what I did, and sort of what the agency did, was that they took those coordinated cycle lengths. They had they already had the green splits as well. Used the green splits that were already there, multiplied the new cycle lengths by their previous green splits, created new green splits, and then used the synchro without the need, like just using sort of directional volumes. They optimize the offsets, and the offset optimization in this case is green band maximization, and they maximize the green bands towards the mostly weighted on the northbound during the PM peak. So after they implemented, as you could see here, they decided to implement from around I think it was around 3 p.m. to 6 p.m. As you can see, the cycle lengths are now nice and coordinated. Green, the time space diagram is showing some very nice green bands happening towards sort of the northbound direction. And then now it's time to track, right? So you've produced a time plan, you've made those changes, and now again, you go back to the same data, same system, everything's there 24/7. You go back to the data and see, okay, what's going on? So traffic volumes, first of all, in order to do an apple-to-apple comparison, we have to see if volumes are the same, which in fact, in this case, there was, again, it was in the heat of the summertime. Again, lots of seasonal traffic here. There was actually a 3%, almost a 3% increase in volumes that happened during the before after. But let's look at sort of what travel time. So previously, when we identified the problem, we did that scan, we were looking at congestion scan. So we just go back to the same thing. So after a few weeks, they went back and then produced the same metric. As you can see, significant reduction. We're not seeing those reds anymore. And travel times were now within sort of normal or acceptable range in this case. Another view of that is to look at the actual travel time graphs as well. So what you're seeing on the screen, the top one is sort of the northbound travel time. As you can see, the before conditions is the top one, where that's the median travel time for, I think that was a month of data. And the bottom one is a few weeks after the traffic signal timing changes were made, and it was coordinated. As you can see, that huge spike was actually completely eliminated. And what you can see here is that, well, there's all these tools, right? You can exactly quantify how much of an impact that had, like 20% reduction, 30% reduction, and different hours throughout the day, both northbound, southbound. You can check all of that and see what the impact was. Another way to look at that would be through report cards. This is a place where I'm talking about like software, like it's about like what the user does versus what the software does. Be able to use the report card. The report card here, you can say this is my before, this is my after. Do a comparison for me. This is in fact a bit old. We now have sort of level of service and delay and that sort of thing. So in this case, you can actually see what was the impact on all the intersections. We don't want to just look at the major, but what happened to the other intersections. All the intersections sort of saw a reduction in the number of split failures that were happening on average. One of them saw an increase. Again, when you see something like this is the best time. You go in to iterate, right? You go back and see if there's something that you can do to be able to address that. Maybe the green split that you considered wasn't sufficient. But even in this case, again, it can be assessed. And then all the data is there to be able to do assessment on sort of costs and emissions. All right, so there's changes in travel time, there's sort of changes in volume, and that can easily be converted into user time cost savings as well as emission savings. There's a very nice report, the FHWA JTRP 2010, which provides some very easy calculations on how to convert travel time changes and volume changes into emission reductions and fuel reductions, fuel usage reduction. So as you can see here, like the estimated savings was around $500,000 a fraction of that was spent on being able to implement the ATSPM system. So I appreciate everyone's time and your patience. I'd be happy to sort of have a discussion or any kind of questions that might come to mind. I'd be happy to answer.
Hey, thank you, Sajad. So if anybody has any questions, if you don't feel like putting in the chat box and you want to unmute, go ahead and do that. As you think about a question or anything that you've seen here in the presentation today for Sajad, let me get you started, Sajad, with one question I've asked the previous presenter on last month webinar. So based on your experience with MyoVision installs, okay, how do you see agencies incorporating this traffic signal data on their workflows? I'm really interested in knowing, you just went through a process here that is iterative, right? You have to go back and forward and learn from the system. So I know that you guys have some intersection health there that can give feedback to the user. But I would like to know, based on, again, on the experience you have with your installs, please comment on dedicated workforce needs and amount of time spent on analysis. So I've heard before, like in Florida, that though an agency was using ATSPM, and every morning they would get these reports and maybe spent an hour, 2 hours, and then the engineers or technicians, whoever was looking at that or looking at that data, would send some directives, some tasks to the technicians. So based on your experience, what you have seen out there and how does that workflow is working?
Great question, Ayrton. I appreciate that. Yeah, for sure. We've seen sort of a variety of agencies, and some agencies for sure, like they have dedicated resources, some don't, and even for the ones who have the resources, to your point, it's about making to some extent some cultural changes in how things are done, right? So this ATSPM data definitely should not create more work. It should help you actually reduce the amount of work that needs to be done and make it faster and smarter. But to your point, it's about like how do you create that workflow of being able to do that, and our experience, like to your point, some of the maintenance issues, for example, we've seen like with the city of Detroit. They, to your point, like every day they get their report and they see which intersections require attention, and that creates the tasks for them to now go and sort of address. When it comes to sort of signal retiming and the actual performance of the intersections, well, might not happen on a daily basis, but again, being able to produce some insights on a regular basis, send that over to the user and say, okay, these are maybe the intersections that require attention based on the information or data from the past 2 weeks. And then it's about like what can that replace in the current workflow at the cities? Can they sort of could this go through the same process of addressing a complaint, for example? So it would sort of need to, our experience with a lot of agencies is that like how do you find those similarities between the current workflows and how can it plug into that that workflow, if that makes sense?
Yes. Again, folks, if you have any questions, please put that on the chat box. In the meantime, I have a few more questions for Sajad.
Sure.
So we know that all of this is great, but there is a cost of equipment, cost of data. It varies from vendor to vendor, right? And of course, that's a concern for agencies. Larger agencies are probably a little easier to accommodate some of those costs. But are you aware, and this is a question also for Patrick, I know Patrick is online here. Are you aware of any innovative programs created to address cost, to maybe sharing this cost, agency partnerships, pool funds, anything that you have seen out there that maybe is an example that other agencies can start looking towards?
Sure. Again, great question, and I'd be happy to let Patrick chime in here as well. But just on my take on it, there's different levels of cost, right? So one cost is the cost of, like, for example, a cloud-based software. But there's also other costs to be able to get to that point. And I would say, like, the cloud-based software is actually the lowest cost required, really. In a lot of cases, you need sort of the right controllers, the advanced controllers having sort of high-res data capabilities, or if it doesn't, be able to, like, get the right interface to be able to get that data. Communications is another thing. Do intersections already have communications? Do they not? And sometimes there's some shortcuts to be able to reduce that time required, like being able to go cellular, for example, as opposed to needing to run fiber, and be able to get there faster. So a lot of the costs associated with really getting to a point where you'd have now access to high quality data is really the infrastructure required in order to get there. And sometimes some agencies, they already have the infrastructure there. So the advanced controllers, the communications, they're already there. And this is just a pure software that can just be applied on top of that. There's so no hardware required in that case. And it's just a cloud-based software that you can access from anywhere. But in terms of funding, like some of the ways that we've seen, again, like when I look at the FAST Act, for example, like there's very detailed breakdown of how the money is spent, and when I'm looking into the details of that, it's actually quite common. I don't quite know how that trickles down into agencies, um, but I've seen quite a few cases there where ITS related technology has been procured through that type of funding. But Patrick, feel free to chime in.
All right, we have a question here, Sajad, from
Sure.
Paul. How often do you see agencies changing timing plans based on using the ATSPM information? So I guess what they're trying to see is, yes, you bought all this equipment, you have it all out there, but are you actually using it? So how often do you see agencies changing timing plans based on this? Or
Great.
maybe sending the information to consultants
For sure.
to work on your timing plan?
Definitely, we've seen quite a few models here. To your point, Ayrton, yeah, exactly. Like we've seen sometimes a consulting that previously was sort of on call is now tasked with sort of leveraging the data. So sometimes it's even the same amount of money, so you're not even spending more because there's now a software available where they can get things done faster and easier. So previously, maybe if just a couple of corridors could be retimed in a year using the data, maybe that could be increased to 10 corridors with the same amount of money, just because this data is just readily available. But we've seen quite a like variety of agencies of like how often they do this. The frequency of that really goes back to first of all, resources that they have. Do they have like a dedicated resource? Some agencies we've seen, like one person is just dedicated to like logging into the software every single day and keep things running and moving and optimizing and improving every single day. Some others take more time, or they need some kind of the system for them to trigger that for them. So again, like going back to intersection health, that's one of the things that it does. So you have the peace of mind in the background that things are performing well until the software is surfacing that there's a green split issue, there's a progression problem, there's a clock drift, there's a detection broken, right? So you sort of, again, depends on how smart the system is. Some of this information could be surfaced, but we've seen sort of a variety of different cases. Definitely during the pandemic, we've seen quite a few cases where the aim was to it turns out like with the reduction in the volumes, the signal timings were designed based on previous volumes, and it was sort of over designed, and some of the cycle lengths were being reduced and that sort of thing. So it depends on the situation. You could have bursts of sort of changes, especially like seasonal changes. We've seen again a hike in the number of changes that are being made.
Yeah, and adding to that, that what's when you mentioned if you have an agency have a dedicated person to look at that's what I'm meaning by having needs for the workforce. You mentioned, yeah, we're not going to bring more work for it, but ideally, for this to really work, we need to have somebody looking at it.
For sure.
On top of that, I don't know if everybody's familiar with your intersection health. So before I go to Andrew's question here, how about if you spend a few minutes just explaining what that intersection health is, those reports that you guys have?
For sure, absolutely. Happy to do that, Ayrton. So intersection health, I sort of alluded to it a little bit here. It's all about that conversion of data into an actual insight, right? There's one of the issues with ATSPM data, again, very valuable information. It's very movement-centric type of information. So if you want to look at the performance of one intersection, 12 movements, you have to produce 12 charts in order to just look at the performance of one intersection. It's time consuming, takes a lot of time, and you sort of need to know, okay, what are you looking for? And sometimes it feels like, and I've done this, again, I've looked into hundreds of intersections, ATSPMs every day, and sometimes it feels like you're searching for a needle in a haystack and being able to really find those nuggets of information that now you can take that and turn it into an actual impact. So with intersection health, what we tried to do, and this is direct feedback that came to us, so we didn't just go and build something, it was based on feedback that we're receiving from agencies that we work with, is okay, can you system actually surface those issues to us? So green split issues, progression issues, if there are phase termination issues, that sort of thing, and we're building on this. So it's just a matter of like adding to that, right? The type of problems. Can you automatically identify that? And that's exactly what we did. So with intersection health, like what you can see on the screen here on the top right, immediately by going to the system, you can see which intersections have a exclamation mark on them. This means that this is intersection we've identified of having one of the issues that I just mentioned. And then once you click on that specific problem, it takes you to a page where it exactly tells you this left turn movement, for example, the southbound left turn movement is experiencing 26% split failures, and the southbound, and during both the permissive and the protected portion of it. And then you can look at the performance of, again, unfortunately, I don't have the demo environment here to be able to show that, but you can look at the performance of the competing movements as well. And this is where you can sort of make a decision that, yeah, it seems like there's an opportunity here to reduce the green time, the maximum green time on opposing through, and add a few seconds to the maximum green on the southbound left, and implement that. So and then again, once you make that change, the system is constantly monitoring your system. So if it happens to address that problem, next time you come in, you're going to be seeing that problem has gone. So this is one of the ways, again, like I think there's a ton of potential for ATSPM data to be able to really provide like recommendations. So right now our system does not provide like the actual recommendation of how much you should change. We're working on that to be able to tell you like our recommendation. Our system is saying like 3 seconds change or something like that. Be able to provide optimization capabilities as well. So if there is a progression problem like the one that we saw, having the tool right in the system, like on demand, you can go in, optimize your timings, optimize your offsets, and if you're happy with it, being able to implement that. So this is sort of a gist of sort of the intersection health or the intelligence piece that we have worked on and is now available.
All right. Thanks a lot. So let me go and shift here to Andrew from West Virginia.
Sure.
His question is, where the screen captures in the presentation from an existing available MyoVision signal analytics platform or something that was custom built for that customer? And if yes, how does MyoVision acquire the high resolution data from the controller? Any in-cabinet hardware required?
Perfect question. So everything that I showed here is through the system. Nothing custom was made. There's quite a variety of different metrics that our system produces automatically. So there's no need to do something custom. Of course, you can customize your own charts and graphs. So this was nothing that was built specifically for a specific customer. These are all available. And the question about sort of being able to, how does you acquire the high resolution data from the controller? There's a couple of ways that we do that. So one is, of course, through advanced controllers using the high res data logger data. And another way is through what's called the interface box, so which interfaces with the controller if the controller does not have that capability. And again, the in-cabinet hardware depends on the infrastructure that you have available. So if you already have communications, if you already have advanced controllers, this is going to be purely software. You do not need any hardware that goes into the cabinet. But if you don't have communications, well, one of the solutions that we have is a cellular, what's called a smart link or a cellular modem that goes into the cabinet and provides connectivity. So it depends on really what you have available. But if you're just interested in the software and you already have the infrastructure, this is pure software. You do not need any hardware in order to get that data.
All right, thank you. I have another question from another Andrew, Mr. Morrow there now. Any thoughts on finding a natural cycle length if the corridor is already coordinated? I would like to verify existing cycle length without setting it free. Is there a specific performance measure that would help with that?
Ah, great question. Great question. So yes, my experience has been, so I've sort of come across a similar case like this, and the metrics I use to be able to identify that, and not necessarily the natural cycle length, but at least you can identify whether the current cycle length is sufficient or not, is by using travel time information plus the phase interval data. So you look at what I would do is that if just to sort of give you an example here, this is a really good question. So in a case like this, like travel time, you're producing travel time graphs, and the travel time graph comes like you're seeing this massive spike in the travel time. If I'm seeing that massive spike in the travel time during the PM peaks, again, I'll go and look at the phase interval graph, and phase interval graph tells me, okay, what is the coordinated cycle? And if in this case it wasn't coordinated, but if it was coordinated, and it was coordinated on, let's say, 100 seconds, that would be a clear indication for me that very, very likely that 100 seconds is not sufficient for this PMP. Now, can I really identify what the correct cycle length is? Hopefully, in the near future, our software will be able to tell you that. But if you want to be able to do that, my experience has been sort of going incremental. So we had this case in a corridor that we were working with, exactly the same. Spike in travel time, cycle lengths were at 90 seconds. So that was a very clear indication that very likely the cycle lengths are suboptimal in this case, because cycle length and delay, they have a pretty steep relationship if the cycles are suboptimal. If they're a bit higher than optimal, well, that doesn't impact delay much. But if cycle lengths are below optimal, they have a massive impact on delay. So in that case, what I did was that we went from, I think the customer that we work with, we went from 90 seconds to 100 seconds, and then optimized the offsets based on that, implemented, and then check the timing, the travel time to see if it worked or not. And then, yeah, in that case, like just by going from a 90 to 100 seconds, like the travel times went completely flat. But yeah, great question. Hopefully I was able to answer that. But if you want more information on that, happy to share that the report with you on more details on that.
Cool. All right, so I'm a big believer on ATSPMs. I think I heard this from Eddie Curtis at the FHWA, that there is signal timing before ATSPMs and there's signal timing after ATSPMs. So if an agency is beginning to think about investing in this type of traffic signal data, what are the steps they need to start planning now? And I think you touched a little bit on that. Controllers, communications, do they need any IT people? So what are some of the things that you see as, yes, we need to start thinking about this now to maybe implement in 1 year, 2 years, 3 years?
For sure. That makes a lot of sense. I mean, again, it's all about sort of starting off with that infrastructure. What kind of infrastructure do you have available? Is it on the corridors that sort of matter to you or not? And then it's about how do you want to get there? Do you want to do that in-house? Do you want that to be sort of more of a managed service, like a cloud-based? Do you want to deal with IT types of stuff? Do you want to deal with physical servers, or do you not want to deal with that? I know, I think it was on one of the ATSPM calls that someone actually mentioned that a mistake in a query, just one mistake of querying the data, they were sort of doing their sort of our DIY type of ATSPMs, cost the agency $60,000 just because of an incorrect query that was happening on the data. So things could get quite complicated, and it depends on, again, I'm of course I am biased towards the company that I work for, but I just want to make sure that sometimes some of the systems are framed in a way that, oh, this is free, for example, but it's not free. Like there's a lot that's happening in the background. There's a lot of cost of IT. There's a lot of cost of servers, cost of maintaining these things. Like this is not just plug and play. Like you can't expect that to be plug and play. You definitely need someone every single day to make sure data is coming in, data is being produced, charts are being produced. Like you need to make sure that things are flowing properly, and these things are not plug and play. So you need to make a decision of, based on the infrastructure that you have, based on the what's it called, the workforce that you have available, the resources that you have available. You need to make that decision. But what I'm trying to say is that I think it's very important to understand all the steps to get there, not just purely the cost of the software itself, because at the end, the software itself is actually quite inexpensive. And then if you replace some of imagine how much a turning movement count costs, and then how much it costs to hire maybe a consulting firm to be able to optimize your timings. Well, maybe if you sort of display some of that budget there, it actually makes sense to have that 24/7 data, have access to something that's monitoring your system constantly, giving you all that information, telling you where the problems are, providing you with tools to be able to optimize. So I think it's important just to understand like which of these journeys you sort of want to select to go with, and then what is your infrastructure looking right now, and what do you need to invest in order to get there faster and in a cost-effective manner.
All right.
Can you hear me okay, Ayrton?
Yes, go ahead.
Oh, sorry. Yeah, I wasn't sure if I was muted there earlier or not, but if you wanted to touch on that funding question that Sajjad mentioned.
Yeah, go ahead. Yes, please, Patrick. Yes, that's Patrick from Myovision. Go ahead.
Yeah, I think I may have been muted earlier, but I said I saw a lot of names on this list here that I recognize. So hello to everyone, even if it's not your faces, at least the names that I'm seeing today. I think the question you posed, Ayrton, and I think Sajjad touched on it, is really interesting, because there's generally two forms when it comes to funding and funding decisions, and a lot of them then trickle down from a federal level or an idea of how that money should flow and how it should be allocated. So in the cases of, let's say, vendors moving towards recurring software, we're in a situation where that makes sense because the software is constantly being updated and constantly changing, but agencies are somewhat limited in terms of budget availability for those operating budgets and things of that nature. So there's kind of two parts that I think will hopefully happen over the next few years. One is from a policy perspective, how people think about funding traffic and transportation is going to change. And we've seen that with some of the mobility as a service type products. So your e-scooters is probably the biggest example. How do we regulate that? How do we allocate funding so that we're using it and picking up data that's interesting to transportation agencies and traffic departments? So that shift, I think, is going to happen, and hopefully that will allocate more of those federal funds. The second part of that is the actual hardware that goes in at the intersection. So again, with ATSPMs, as Sajjad was saying, there's you can leverage a whole bunch of different options out there, but you do need to have the certain technology that's laid out by the FHWA, even if it's just functioning loops at an intersection to pick up those, to pick up the right data points. In that particular case, I do think there's some interesting things going on that may allow agencies to partner with either large private firms. I know Amazon distribution factory has, distribution centers have looked at doing this in some areas where they help finance some of the upfront hardware cost, and then the agencies get access to some of the data that they're able to pick up from that. So those are, I mean, funding is always a challenge. There's never enough time for people who are working general in traffic, and often there isn't enough money to do the upgrades that we would really like to do to get our network to where it needs to be. So if I can look at maybe 2 silver linings, I think those will be helpful in the years to come as well.
Yeah, great. So thank you very much. I'm not seeing any more questions here. Thank you very much, Patrick and Sajad. I would like to take the opportunity and mention to you that our next webinar is going to be in about a month from now. And what I'm planning to do, I already connected with some folks in Georgia. I don't know how many of you are familiar with the RTOP program there, the Regional Transportation Operation Program, where they're getting several agencies together and working again towards the common goal, okay, of improving traffic operations. So we're going to have Intellite controllers kind of working together with us here at TTAP and telling a little bit of the story of the RTOP there, the successful story of the RTOP program in Georgia. So I'll send you information about that webinar on the next few weeks here. Please, before you go today, if you have not signed in on the chat box, please put your name in there so we can send your certificate. Anybody else have any other comments or questions for our presenters today? All right, it's a beautiful day here in East Tennessee, I guess. Based on the number of people that missed the webinar, they're probably using that beautiful day to go out there and enjoy the weather. So thank you very much for participating on the webinar today. Thank you again, folks from IOVision, on the participation on the presentation here. And I'll see you next time.
Thank you, everyone.
Thanks, everyone. Thanks, Ayrton.
Thank you.